Okay, 3.5, higher degree polynomial functions and graphs. So looking at a polynomial function, a degree n in the variable x. Remember, degree is your highest exponent. So that's going to tell us, we're going to look at that highest exponent and tell us what the degree is. Now, there are two different types of degrees, right? There's an even and an odd degree. And depending on the even and odd, will tell you a lot of information. So let's first look at a cubic function. A cubic is 3, so it's odd. This is an odd function. And when there's an odd function, the arrows go in opposite direction. So it looks something like this or like this. Noticing our arrows, one's pointing up and one's pointing down. Let's go to the next one. A quartic function, well, that's anything x to the 4th power. Okay, quartic is 4. So this is an even graph. And when there's an even graph, the arrows are in the same direction. They're either going up or they're going down. Now, what I just graphed was a parabola, right? So that's x squared. But again, x squared, 2 is even. So it's going in the same direction. Okay, let's look at an example. If this was my graph, the arrows are going in the same direction, so I know it's even. If I asked you to state the domain, okay, the domain for all even graphs, this is for all even graphs. The domain is negative infinity. Remember, you move in from your left to your right, negative infinity to positive infinity. Our range, again, for all even, okay, our range starts from the bottom and you move up through the graph. So here this starts at 0 and goes to positive infinity. Hard bracket at 0 because it's sitting right at 0. Okay, can't be below. Okay, if we asked to look at the decreasing values or the increasing values, remember we're looking at your x values. So we approach this way. Up here, that's negative infinity and stops at 0. Okay, and then when does it increase? Well, we're still looking at our domains. We're going up and out, goes from 0, hard bracket, all the way up and out to positive infinity. Now, here's something a little bit different. We have our maximum and our minimum values. Okay, this is a review from last section. Remember, our maximum and minimum, the values are the y of the vertex. Okay, now you find your maximum and minimum values at the turning points, right? That's when your graph turns to go in a different direction. Now here's what's new. The absolute max and the absolute min. Well, what does absolute value do to a graph? It makes it positive, right? For example, if I had a graph that looked like this, okay, and I needed it to be positive, this part down here that's negative would turn back up, right? So our graph would now look like this, okay? That's what absolute value does. It turns it up. Well, same thing here. The absolute value, when P of C is greater than or equal to P of X, and I'll show you what that means in a little bit. It's a maximum value. It's a minimum value when it's less than. And then you have the local maximum and the local minimum. Now, these are the same. If you notice, P of C is greater than or equal to P of X for the maximum and minimum. So the local and absolute values are pretty much the same. But what I need you to remember with the absolute values is it makes the graph positive. It brings it above the x-axis. Let's look at some examples. So I gave you guys two graphs here. Okay, now they're not on an x or y axis because I don't need an x or y axis. This first one here to the left, this is my f of x equation, and I forgot to label this one, but this is my g of x equation. Okay, so first it says the local extreme points of f. Okay, well, what are your extreme points, right? Your extreme points are going to be the minimum, the local minimum, and the local maximum. So see local, now the local extreme points are your minimum and maximum of f. Okay, so let's first look, here's my f, graph, let's first talk about the minimum. The local minimum is at the valley, right, at the base of it. So your points are A comma B and E comma H. Those are our minimum. And our maximum for F is at the top. It's like at the top of the hill, C comma D. Okay, now let's go to B. Find the local extreme points of G. Well, G, we have, again, let's talk about our minimum. Down at the bottom, the points are J and K. And maximum, up at the top, M and N. Okay, so now this is saying, C says, where are the absolute extreme points of F and G? Okay, so what you really want to do here is you want to look to figure out your absolute extreme points at the range. Okay, now for an even graph, okay, for an even graph, remember the arrows go in the same direction, and odd, they go in opposite direction. So that tells us a lot, okay? For the odd graph, which g of x ends up being an odd graph, our range is negative infinity to positive infinity. So we will have no absolute value. So for g of x, for here, g of x, there is no absolute extreme points. And again, why? Because our range is all real numbers, negative infinity to positive infinity. Okay? But let's look at f of x. Since our even graphs, the range is usually zero. I'm sorry. Yeah, your range is usually 0 to positive infinity. When you have the points of A, B, and E, H, okay, that's going to be the concern. Now, I drew this kind a little wrong. The EH should be lower. Let's make that EH lower than AB, okay? And the reason why this is my EH value, because they would never be dead even. My extreme and my absolute extreme points, the one I need to look at is EH because it's lower than AB. So what we're going to look at for our X graph, sorry, I have to go below, is the EH point because it's the lowest point on that graph. Now, in order to get it to state that it's the absolute minimum point as EH, now, when we talk about the minimum, remember the minimum is the y of our vertex. So if our vertex is EH here, y is our minimum value. Okay, so since y is our minimum value, we need to rewrite it. So the range, and this is your answer right here, your answer, because the absolute value, it changes the range. The range now has to start at h and go to positive infinity instead of starting at 0 like it was up here. Okay, it no longer starts at 0 anymore because the absolute value is going to make it start at h to positive infinity. Okay, let's look at end behaviors and turning points, right? End behaviors, if A is going to be your very first coefficient. If A is greater than 0, N would be odd, okay, which is really interesting. A is less than 0, N is odd, right? Or I'm sorry, if A is great, let me rephrase this. If A is 0 and N is odd, meaning your degree is odd, if A is greater than 0, your graph looks like this, where your arrow starts on the right-hand side and then goes down, okay? If A is less than 0, then your first arrow starts on the left-hand side and goes down. Okay, those are for the odd graphs. Now let's look at what it looks for even. If A is greater than 0 and your degree is even, then it's up. And if A is less than 0 and N is even, your graph is going down, which we know that from quadratic functions. We're just not as familiar with like x cubed. Okay, x-intercepts, that's just when the graph, that's just when the graph hits the x-axis. So here it hits once. Okay, so if it hits once, you would have one solution. Okay, here it hits twice, so two solutions. And here it hits 3 times, so that's 3 solutions. Okay, let's look at an example. So this example is actually number 59 from your book. Okay, it's 59 from your book. So what I did was I took this equation and I went to my calculator because it's going to say use your graphing calculator. And I went to y equals and I plugged it in. Now I also changed my window range. Okay. And how did I change my window? Well, I can see that my 0, c, this very last term is 84. It's going to come all the way up here to 84. So I changed it to 100 and 100. I made my y values go from 100 to negative 100. Or I'm sorry, negative 100 to 100. Okay. So again, how did I figure that out? Because I looked at that very last term. So depending on where that very last term is, your C term, you can adjust your window range. Okay. Domain. So if I look at my domain, okay, I can see that, well, first off, I can see that it's an odd graph. Okay. So if it's an odd graph, I know that my domain is going to be negative infinity to positive infinity. Okay. Local minimum points. All right. So how are we going to figure your minimum points? Well, you're going to go to second trace. And in second trace, you'll see minimum. Okay. You're going to hit enter on that. It's going to say left bound. You want to make sure your point is on the left side of your minimum. So if we look at our graph here, it would be on this side of your minimum value. And then you'd hit enter. Then right bound. We've done this before. So you're going to move your little blinking guy over to the right bound. Then it says guess. Yes, you want it to guess. And it's going to give you the answer of negative 4.74, comma, negative 27.03. Okay, we want to state, it says tell if any of an absolute minimum point. Well, there's no absolute minimum point. There's none. And why is there none? There's none because the domain and the range for this instance is negative infinity to positive infinity. Okay, so all of the values are taken care of. There's no absolute minimum. Remember, this only happens when you have an even graph. Okay, let's look at C. It wants to know the maximum. So again, you're going to do second trace. You have to run another test. But this time, when you do second trace, you're going to hit maximum. You're going to follow the steps, and it will get you 0.07, comma, 84.07. We're always going to round 2 decimal places out. Okay, and then it asks, well, is there an absolute max point? And the answer is no. I know my maximum is up here, but because my left side of my graph keeps going up to positive infinity, there's no maximum value that would affect my there's no maximum absolute point. That's what I'm trying to say. Okay, our range, well, I've already stated before, negative infinity to positive infinity. Determine the intercepts. Okay, I wrote them down. but you can find them on your calculator. Second trace, and this one you're going to hit the zeros. You want to figure out the zeros. So since it runs through it 3 times, you're going to need to run the test 3 times. But in this case, right, we can see that we can see -6. We can see that it hits at -3. And then we just don't know what this one on the right-hand side is. We're not guessing, okay? And actually, this one here, I graphed it kind of wrong. Now that I look at my calculator, it's -3.19. And then the one on the right, the positive one, is 2.19. Now, it does ask for, when it says all intercepts, that means the x and the y. So the way you figure out the y-intercepts is by taking each one of these numbers and plugging it back into your equation. So what would happen if you plugged -6 in there? Oh, no, I'm sorry. I lied. The y-intercept is where it hits the y line. Duh. Sorry. Okay, so where it hits the y line is all the way up here at that maximum at 84. Okay, so my y-intercept, I'm still laughing at my dumb mistake, is 84. Okay, last 2 questions. Increasing intervals and decreasing intervals. Okay, looking at this, where does it increase and where does it decrease? So we have a couple. What's the first question? Increase. Okay, where does it increase? Well, it increases really from starting here all the way to like here. Okay, so again, use your calculator, right? So that increases at -4.74, 0.07. Okay, that's your increase. All right, where does it decrease? Let's look at that. Well, where it decreases, I'm going to highlight in purple, goes from here to here, stops, picks back up, and goes from here to here. That's our decreasing, right? So we're going to have 2 different parentheses with the union, okay, because we're going to have to connect it. Again, where does it decrease is my purple values. So you can get those purple values on your calculator. Or really, if you think about it, it's exactly from your increasing intervals. It stops at the increasing intervals. So it goes from -infinity to -4.74. It stops. It picks back up at 0.07 and goes to positive infinity. Make sure those look like soft brackets. Okay, that's the lesson for today.